Hey everybody, this is our second review lesson out of 6 for our upcoming final for Integrated Math 2, and be looking for your IM3 lessons next year. I'll be posting those. So on these handouts that we're giving you that you have in your little hands here, we have two proofs. One of them is an algebra proof. Okay, so we're going to solve this equation, and we're going to solve it like we normally would. There's a couple of ways to solve it. There's probably more than 2 ways. I'll show you 2 ways. Either way is fine. And then over here, we just got to write a reason why we're doing that. So put down our given equation. So there's our given equation. Now probably most of you guys will distribute this -4 through, and that is great. Let's do that. So -4 times 11 is -44. -4 times 2 is -8. And then next you're going to go +8 +8. So we're going to use the addition property and adding 8 to both sides. And then finally divide both sides by -44. We get -2. Okay, that way is terrific. Here's another way if you want to do it this way. There's your given. And then instead of distributing the -4 through, we can divide both sides by -4 right off the bat. When we divide this by -4, that goes away. We're left with 11x plus 2. When we divide this by -4, we get -20. Okay, and then we can go ahead and go -2 minus 2, and -20 minus 2 is -22, and then divide. You get the same answer, okay? So by division property right there, okay? Just make sure you're writing these reasons right here, okay? You're going to have at least one of those on your upcoming test. Okay, so here we're trying to prove, let's see, that this segment is congruent to this segment. Well, our goal is we're going to get this triangle congruent to this triangle. Then we can say this reason by CPCTC. I don't think we'll need all of these. In fact, we'll probably use 5 of these. Let's see. So let's go ahead and put this first given down right here and mark the figure. So I marked this figure so I can see, is it going to be side angle side, side side side, angle side angle, angle angle side, whatever, okay? All right, I don't see anything yet. Well, actually, I see vertical angles. I'll do that after I throw this next given down. Now, the reason why I separated these givens, you guys, is so we can see that this given gives these markings. Notice I marked this angle and this angle right here. Okay, now these are vertical angles. Make sure you say them in order. So I said NLM, angle NLM, and angle PLQ are congruent because these are vertical angles. Vertical angles are congruent. Okay, now this goes angle, angle, side. See how this side is not included between these two angles? It's not this side right here. This would be, if it was this side right here, it would be angle, side, angle. But it's not. It's a non-included side, so it's angle, angle, side. So these triangles are congruent by angle, angle, side congruency theorem. And then we can say our proof, corresponding parts of congruent triangles are congruent. That's what CPCTC is. All right, so let's find the values of x. Okay, these guys between these parallel lines are supplementary. Okay, these guys are congruent. They're either congruent or supplementary, okay, when you have parallel lines. So if one's an acute angle and one's an obtuse angle, then that means that they're the supplementary ones. So add those up to be 180. Okay, so we get combining like terms and subtracting 40, and then dividing by 4, we get x equals 35. Okay, these guys are congruent, so set those guys equal to each other, subtract, divide. Whoops, divide, I forgot to divide, so we get x equals 8 right there. Let me put that in there, sorry. X equals 8. Okay, all right, so that's our answer right there. Okay, so these next ones here, we're going to solve for x here. Okay, so these ones look like they're vertical angles, so those guys are congruent. So you can see this line and this line intersecting, and they give us these vertical angles. This line is a deception. It's trying to trick you so you can't see the vertical angles, okay? All right, so subtract 3, you get 72, and divide by 6, and we get 12 on that. All right, so here, straight line. Use the straight line 180 trick on that one, okay? So those add up to 180, subtract, and divide, and get 20. Okay, so here, you guys, these ones, we use the theorem that says this exterior angle is equal to the sum of these remote interior angles. So this equals this one plus this one. Same here. This equals this one plus this one. Okay, let's go ahead and do that. We'll combine like terms. 30 plus 2 is 32. And then I'm going to subtract 4x over here from 6x and get 2x. And I'm going to subtract 8 over here from 32 and get 24 and divide 12. Okay, over here, and then we'll combine these like terms. That's going to get us 37x, what, plus 9 right there. Okay, subtract 9 and then divide by 37 and we get 3. Okay, so here, all right, this one you're going to get a fraction. In fact, I think it's a negative fraction, a negative decimal. Okay, so since that's 90, all of them add up to 180, but take out the 90, these guys are, add up to 90 also. And the theorem says this: the acute angles of a right triangle are complementary. These guys add up to 90. All right, so add these up, 2x, and then we get plus 103, and so we subtract 103, we get negative 13. All right, and then we divide and we get negative 6.5. So plug that in. Okay, we can get x to be negative because when you plug it in, you get this angle up here to be positive. So I get x to be 36.5 degrees. All right, so this one here, this is 2x plus 8, so is this angle. That's 2x plus 8 also. And then this exterior angle equals the sum of these two remote interior angles right there. Okay, let's combine like terms. Subtract 18, divide, and we get 6. Okay, and then so angle A is 7 times x, which is 7 times 6, or 42. All right, find the sum of the angles of the convex polygons with the number of sides. Well, the sum of the angles is n minus 2 times 180. Okay, so 8 minus 2, and then 11 minus 2 times 180, and then crank that out, and those are our answers. Sorry about that. Those are our answers. Okay, this one says find the measure of one of the interior angles of the regular polygon with a number of sides. So we do what we did in the last part. We do n minus 2 times 180. Okay, so 6 sides gives us, they add up to 720. 10 sides add up to 1440. Okay, and so since it's regular, all the angles are equal. So here I'm going to divide 720 by those many angles and divide 1440 by those many angles. Okay. And that's what you get, okay? All right, so two sides of a triangle have the following measure. Find the range of the possible measures of the third side. Okay, so what you do is you add them and subtract them. The third side is going to be larger than the difference of them, but smaller than the sum of them. So add them and subtract them, and that'll give you your upper boundary and your lower boundary. Okay, so subtract these two is going to be less than the third side, and then the third side is going to be less than the addition of those two. So that's all you do. Add them, subtract them. Same with this one. Add them and subtract them. Okay. All right, so here we're going to solve for x. Okay, so since these two sides are equal, these two angles are equal. So float a 54 up there, and then those angles add up to 180, and solve for x, and you get 72. Okay, since these two sides are equal, then this angle right here is also 65 right there. So we'll find out this angle to be 50 right there. Okay, and if that's 50, this angle's 50 right there. And then since these two sides are equal, then this 50 equals this 50 right there. Okay, so now we can add these up, and so 50 plus 50 plus x is going to get us, x has to be 80 to work on that one. Okay, so let's solve for x in each parallelogram. Okay, this one's kind of a deception right here, you guys. This parallelogram, opposite sides are equal. So 2x plus 15 equals x plus 15. Subtract 15 from both sides, and we get 2x equals x. And you're thinking, what? Well, 2 times what number is the same as that same number? Well, 2 times 0 is the same as 0. Okay, and if you think about it, the only way I'm going to make this work is if x equals 0 on that. So x equals 0. All right, okay, these, it's a parallelogram. These angles right here are supplementary, okay? Consecutive angles are supplementary. This angle and this angle are equal. So these ones are equal. Consecutive angles are supplementary. So let's add them up to be 180. Combine like terms, subtract and divide, and we get 10. Okay, all right, so find the missing lengths, and these triangles are similar. Okay, now you can draw these triangles separately. I'm saving time, you guys, because otherwise this video would take a long time and take me a long time. And I want to get out of here. It's 4 o'clock, so anyways, so what I'm going to do is do piece over whole equals this piece over the whole right there. So if they're similar, then that means that these lines are going to be parallel. And so we can do piece over whole when the lines are parallel. Okay, so we're combining a couple of theorems right there, but left e over whole equals left e over whole. So here we go. I'm going to go 9 over 18 equals, I'll call this x over 22. And when you cross multiply, we get x equals 11 right there. Okay, all right, these triangles are similar, so I'm going to go top over bottom equals top over bottom. I'm going to call this piece x right there. Okay, so there we go. Okay, so cross multiply and divide, and we get 22 on that. Okay, one more, you guys. Okay, so this one here, you guys, since they're similar, then that means these lines are parallel. And if these lines are parallel, I can do piece over the whole equals this piece over the whole, because I'm given the pieces and the whole. So there's several ways you can do it. This is the quickest way. Piece over whole, piece over whole. Cross multiply, we get x equals 9. All right, you guys, hope that helps. Take care.